Welcome to the Healthaibrief, breaking down the AI shaping our world one concept at a time. So in our last episode we explained neural networks, the fundamental architecture for learning from data. But that still doesn't explain the huge leap in performance that we've seen in AI and machine learning in recent years. So how are systems now able to analyse a CT scan or a pathology slide, or even imitate works of Shakespeare with such accuracy? The answer is by making those neural networks deep. So whereas a simple neural network may have its input layer, output layer, and just a few of those so-called hidden layers in between, in deep learning, it's simply a term we use for training very deep neural networks, which contain many of these hidden layers between the input and output. So the processing layers that there's many of. In a standard neural network, it's a short chain for processing data, whereas in a deep neural network, it's a multi-stage manufacturing line where each stage performs an increasingly sophisticated task. Let's use the example of analysing a chest CT for a cancerous nodule. So the first hidden layer gets the raw image pixels from the input layer. Its job's incredibly simple to spot basic features like a bright edge, a dark curve, or a patch of texture. It then passes a map of these simple findings to the next stage. The second layer only sees this map of edges and curves, and its job is to then combine them into slightly more complex shapes like vessel walls or parenchymal tissue. The next layer combines those shapes into even more abstract, kind of nodule-like objects. And this process of hierarchical abstraction is directly analogous to how our own visual cortex works. Raw light signals hit the retina, and that information is passed up a chain of neurons with different groups specializing in detecting edges, then motion, then orientation, and all of this feeds into our final seamless interpretation of things in the real world. A deep network does the same for pixels, learning the most efficient visual pathway to the right answer all on its own. So why is this distinction critical? Why is it important to understand this? So first, deep learning models are notoriously black boxes. So because the features they use are machine generated and often have no direct clinical name that we might recognize, it's very difficult to ask the system why it made a specific decision. So in the examples I've given, I've used analogies just to try and illustrate the points, but in reality the features aren't necessarily things that we'd recognize. And in fact, there's entire fields of research dedicated to trying to find out this sort of information about how deep learning models are making their decisions. But it's also a major safety consideration when we think about how we might want to validate or override the conclusions of models. Second, this power comes at a cost, an enormous appetite for data. To learn the complex hierarchy correctly, a deep network needs to see vast quantities of high-quality, expertly labelled examples to learn from. When you're appraising a paper on a deep learning tool, the size, quality, and diversity of its training dataset is one of the most important things to note. And finally, the process creates hyper-specialised experts. So a deep network trained to find lung nodules is a world-class master of that trick. But they tend to be fairly useless for other functions. So say analysing a mammogram or a CT scan of a head if it's been trained just to detect lung nodules. And they tend to have very little generalisable medical knowledge. Again, people are trying to develop more generalisable solutions, but it's an important consideration. So they're powerful instruments, but for single, narrow purposes. So that's deep learning in a nutshell. Not a new concept, but the application of very deep neural networks to learn complex hierarchical patterns directly from data. And it's the engine behind the revolution that we're currently seeing in recent years. So if you found that useful, please hit subscribe or follow in your podcast app so you don't miss future episodes.